Acids, Bases and Salts. CBSE Class 10 Science Chapter 2 Notes. Indicators. Indicators are substances which indicate the acidic or basic nature of the solution by the color change. Types of indicators. There are many types of indicators. Some common types of indicators are natural indicators. Indicators obtained from natural sources are called natural indicators. Litmus, turmeric, red cabbage, China rose, etc. are some common natural indicators used widely to show the acidic or basic character of the substances. Litmus. Litmus is obtained from lichens. The solution of litmus is purple in color. Litmus paper comes in two colors, blue and red. An acidic turns blue litmus paper red. A base turns red litmus paper blue. Turmeric. Turmeric is another natural indicator. Turmeric is yellow in color. Turmeric solution or paper turns reddish brown with base. Turmeric does not change color with acid. Red cabbage. The juice of red cabbage is originally purple in color. Juice of red cabbage turns reddish with acid and turns greenish with base. Number 2, olfactory indicator. Substances which change their smell when mixed with acid or base are known as olfactory indicators. For example, onion, vanilla, etc. Onion. Paste or juice of onion loses its smell when added with base. It does not change its smell with acid. Vanilla. The smell of vanilla vanishes with base, but its smell does not vanish with an acid. Olfactory indicators are used to ensure the participation of visually impaired students in the laboratory. Number 3, synthetic indicator. Indicators that are synthesized in laboratory are known as synthetic indicators. For example, phenolphthalein, methyl orange, etc. Phenolphthalein is a colorless liquid. It remains colorless with acid but turns into pink with a base. Methyl orange is originally orange in color. It turns into the red with acid and turns into yellow with base. These are few indicators where we can see the indicator name, original color, acid as well as base. Acids. Acids are sour in taste, turns blue litmus red and dissolve in water to release hydrogen ions. Examples: sulfuric acid H2SO4, acetic acid CH3COOH, nitric acid HNO3, etc. Properties of acids. Acids have a sour taste, turns blue litmus red. Acid solution conducts electricity, releases hydrogen ions in aqueous solution. Let's see the types of acids. Acids are divided into two types on the basis of their occurrence, that is natural acids and mineral acids. Number 1, natural acids. Acids which are obtained from natural sources are called natural acids or organic acids. For example, methanoic acid HCOOH, acetic acid CH3COOH, oxalic acid C2H2O4, etc. Here are few examples of the acids and their organic sources. As we can see, acetic acid can be obtained from vinegar, ascorbic from guava or amla, citric acid from lemon, orange or any other citrus fruits, lactic acid from sour milk or curd, methanoic from ant sting or nettle sting, oxalic acid from tomato and tartaric acid from tamarind. Number 2, mineral acids. Acids that are prepared from minerals are known as mineral acids. For example, inorganic acid, man-made acids, or synthetic acid are also known as mineral acid. For example, hydrochloric acid, that is HCl, sulfuric acid H2SO4, nitric acid HNO3, carbonic acid H2CO3, and phosphoric acid H3PO4, etc. Now let's look at the chemical properties of acid. Number 1. Reaction of acid with metal. Acids give hydrogen gas along with respective salt when they react with a metal. Metal plus acid gives salt plus hydrogen. Now let's look at some examples. Hydrogen gas and zinc chloride are formed when hydrochloric acid react with zinc metal. Zn plus HCl gives ZnCl2 and hydrogen. Hydrogen gas and sodium sulfate are formed when sulfuric acid react with sodium metal. 2Na plus H2SO4 gives Na2SO4 plus H2. Test for hydrogen gas. The gas evolved after reaction of acid with metal can be tested by bringing a lighted candle near it. If the gas burns with a pop sound, then it confirms the evolution of hydrogen gas. Burning with pop sound is the characteristic test for hydrogen gas. Reaction of acids with metal carbonate. Acids give carbon dioxide gas and respective salts along with water when they react with metal carbonates. Metal carbonate plus acid gives salt plus carbon dioxide and water. For example, hydrochloric acid gives carbon dioxide gas, sodium chloride along with water when reacts with sodium carbonate. Na2CO3 plus 2HCl gives 2NaCl plus CO2 plus H2O. Sulfuric acid gives calcium sulfate, carbon dioxide gas, calcium sulfate and water when it reacts with calcium carbonate. CaCO3 plus H2SO4 gives CaSO4 plus CO2 plus H2O. Nitric acid gives sodium nitrate, water and carbon dioxide gas when it reacts with sodium carbonate. 2HNO3 plus Na2CO3 gives Na2NO3 plus H2O plus CO2. Number 3. Reaction of acid with hydrogen carbonates or bicarbonates. Acids give carbon dioxide gas, respective salt and water when they react with metal hydrogen carbonate. Acid plus metal hydrogen carbonate gives salt plus carbon dioxide plus water. For example, sulfuric acid gives sodium sulfate, carbon dioxide gas and water when it reacts with sodium bicarbonate. In equation form, it can be written as 2NaHCO3 plus H2SO4 gives NaCl plus CO2 plus H2O. Test for evolution of carbon dioxide gas. Carbon dioxide turns lime water milky when passed through it. This is the characteristic test for carbon dioxide gas. The gas evolved because of reaction of the acid with the metal carbonate or metal hydrogen carbonate turns lime water milky. This shows that the gas is carbon dioxide gas. This happens because of the formation of a white precipitate of calcium carbonate. CaOH twice plus CO2 gives CaCO3 plus H2O and CaCO3 plus CO2 plus H2O gives CaHCO3 twice, that is calcium hydrogen carbonate. But when excess of carbon dioxide is passed through lime water, it makes milky color of the lime water disappear. This happens because of formation of calcium hydrogen carbonate. As calcium hydrogen carbonate is soluble in water, thus the milky color of solution mixture disappears. What is common in acids? Acids give hydrogen gas When they react with metal, this shows that all acids contain hydrogen. For example, hydrochloric acid, sulfuric acid, nitric acid, etc. When an acid is dissolved in water, it dissociates hydrogen. The dissociation of hydrogen ion in aqueous solution is the common property in all acids. Because of the dissociation of hydrogen ion in aqueous solution, an acid shows acidic behavior. Let's look at some examples. Hydrochloric acid gives hydrogen ion and chloride ion when it dissolved in water. HCl gives H plus and Cl minus. And CH3COOH, that is acetic acid, gives acetate ion and hydrogen ion. So let's look at some acids. Strong acids. An acid which is completely ionized in water and produces hydrogen ion is called strong acid. For example, hydrochloric acid, sulfuric acid, nitric acid. What are weak acids then? An acid which is partially ionized in water and thus produces a small amount of hydrogen ion is called a weak acid. For example, acetic acid, carbonic acid, etc. When a concentrated solution of acid is diluted by mixing water, then the concentration of hydrogen ions or hydronium ion per unit volume decreases. Bases. Bases are bitter in taste, have soapy touch, turns red litmus blue and gives hydroxide ions in aqueous solution. For example, sodium hydroxide, NaOH, calcium hydroxide and potassium hydroxide. So let's look at some properties of bases. They have a bitter taste, soapy in touch, turns red litmus blue, conducts electricity in the solution and releases hydroxide ion in aqueous solution. What are types of bases? Bases can be divided into two types, water soluble and water insoluble. The hydroxide of alkali and alkaline earth metals are soluble in water. These are also known as alkali. For example, sodium hydroxide, magnesium hydroxide, calcium hydroxide, etc. Alkali is considered as a strong base. Let's look at the chemical properties of bases. Reaction of base with metals. When alkali or base reacts with metal, it produces salt and hydrogen gas. Alkali plus metal gives salt plus hydrogen. For example, sodium hydroxide gives hydrogen gas and sodium zincate when reacts with zinc metal. Similarly, sodium aluminate and hydrogen gas are formed when sodium hydroxide react with aluminium metal. Second property, reaction of base with oxides of nonmetals. Nonmetals, nonmetal oxides are acidic in nature. For example, carbon dioxide is a nonmetal oxide. When carbon dioxide is dissolved in water, it produces carbonic acid. Therefore, when a base reacts with nonmetal oxide, both neutralizes each other, resulting respective salt and water. Base plus nonmetal oxide gives salt plus water. We all know that nonmetal oxides are acidic in nature. For example, sodium hydroxide gives sodium carbonate and water when it reacts with carbon dioxide. And similarly, calcium hydroxide gives calcium carbonate and water when it reacts with carbon dioxide. The third property is neutralization reaction. An acid neutralizes a base when they react with each other and respective salt and water are formed. That is, acid plus base gives salt plus water. Since the reaction between acid and base both neutralize each other, hence it is also known as neutralization reaction. Let's look at some examples. Sodium chloride and water are formed when hydrochloric acid react with sodium hydroxide, which is a strong base. Similarly, calcium hydroxide is formed along with water when hydrochloric acid react with a calcium hydroxide, which is a base. The fourth property is reaction of acid with metal oxide. Metal oxides are basic in nature. Thus, when an acid reacts with a metal oxide, both neutralize each other. In this reaction, the respective salt and water are formed. Acid plus metal oxide gives salt plus water because metal oxides are basic in nature. Let's look at some examples. Calcium is a metal. Thus, calcium oxide is a metallic oxide which is basic in nature. When an acid such as hydrochloric acid reacts with calcium oxide, neutralization reaction takes place and calcium chloride along with water is formed. Similarly, when sulfuric acid react with zinc oxide, zinc sulfate and water are formed. Here are some reactions. So what is common in all bases? A base dissociates hydroxide ion in water, which is responsible for the basic behavior of a compound. For example, when sodium hydroxide is dissolved in water, it dissociates hydroxide ion and sodium ion. Similarly, when potassium hydroxide is dissolved in water, it dissociates hydroxide ion and potassium ion. Thus, the base shows its basic character when because of dissociation of hydroxide ion. In neutralization reaction, when an acid reacts with a base, the hydrogen ion of acid combines with hydroxide ion of base and forms water. As these ions combine together and forms water, instead of remaining free, thus both neutralize each other. For example, when sodium hydroxide, which is a base, react with hydrochloric acid, sodium hydroxide breaks into a sodium ion and hydroxide ion, and hydrochloric acid breaks into hydrogen ion and chloride ion. Hydrogen ion and hydroxide ion combine together and form water, while sodium ion and chloride ion combine together in form of sodium chloride. You can see in this reaction below. So what is dilution of acid and base? The concentration of hydrogen ion in an acid and hydroxide ion in a base per unit volume shows the concentration of acid or base. By mixing acid to water, the concentration of hydrogen ion per unit volume decreases. Similarly, by adding a base to water, the concentration of hydroxide ion per unit volume decreases. This process of addition of acid or base to water is called dilution, and the acid or base is called diluted. The dilution of acid or base is exothermic. Thus, acid or base is always added to water and water is never added to acid or base. If water is added to a concentrated acid or base, a lot of heat is generated, which may cause splashing out of acid or base and may cause severe damage as concentrated acid and base are highly corrosive. So what is the strength of acid and base? Acids in which complete dissociation of hydrogen ion takes place are called strong acid. Similarly, bases in which complete dissociation of hydroxide ion takes place are called strong bases. In mineral acid, such as hydrochloric acid, sulfuric acid, nitric acid, etc. Hydrogen ion dissociates completely and hence they are considered as strong acids. Since inorganic acid hydrogen ions do not dissociate completely, so they are weak acid. For water or neutral solution, pH is equal to 7. For acidic solution, it is less than 7, and for basic solutions, it is greater than 7. What is universal indicator? Using a litmus paper, phenolphthalein, methyl orange, etc., only the acidic or basic character of a solution can be determined. But the use of these indicators does not give the idea about the strength of acid or base. So to get the strength as well as acidic and basic nature of a given solution, universal indicator is used. Universal indicator shows different color over the range of pH value from 1 to 14 for a given solution. Universal indicator is available both in the form of strips and solution. Universal indicator is the combination of many indicators such as water, propanol, phenolphthalein, sodium salt, sodium hydroxide, methyl red, bromothymol blue, monosodium salt, and thymol blue monosodium salt. The color matching chart is supplied with a universal indicator which shows the different colors for different values of pH. pH value shown by different colors role of pH everyday life. pH in our digestive system. Dilute HCl or hydrochloric acid help in digestion of food, that is proteins, in our stomach. Excess acid in stomach causes acidity or indigestion. Antacids like magnesium hydroxide, also known as milk of magnesia, or sodium hydrogen carbonate, that is baking soda, are used to neutralize excess acid. Tooth decay caused by acids. The bacteria present in our mouth converts the sugar into acids. When the pH of acid formed in the mouth falls below 5.5, tooth decaying starts. The excess acid has to be removed by cleaning the teeth with a good quality toothpaste because these kinds of toothpaste are alkaline in nature. Soil of pH and plant growth. Most of the plants have a healthy growth when the soil has a specific pH which is close to 7, which should be neither alkaline nor highly acidic. Therefore, compound X is sodium hydroxide, compound A is zinc sulfate, compound B is sodium chloride, and compound C is sodium acetate. Now let's look at the salts. Salts are the ionic compounds which are produced after the neutralization reaction between acid and base. Salts are electrically neutral. There are some salts, but sodium chloride is the most common among them. Sodium chloride is also known as table salt or common salt. Sodium chloride is used to enhance the taste of food. What are the characteristics of salts? Most of the salts are crystalline solid. Salts may be transparent or opaque. Most of the salts are soluble in water. Solution of the salts conduct electricity in their molten state also. The salt may be salty, sour, sweet, bitter, and umami, that is savory. Neutral salts are odorless. Salts can be colorless or colored. Family of salt. Salts having common acidic or basic radicals are said to belong to the same family. For example, sodium chloride and calcium chloride belong to chloride family. Calcium chloride and calcium sulfate belongs to calcium family. Zinc chloride and zinc sulfate belong to zinc family. What is a neutral salt? Salt Salts produced because of the reaction between a strong acid and a strong base are neutral in nature. The pH value of such salts is equal to 7, that is neutral. For example, sodium chloride, sodium sulfate, potassium chloride, etc. Sodium chloride is formed after the reaction between hydrochloric acid and sodium hydroxide. Sodium sulfate is formed after the reaction between sodium hydroxide and sulfuric acid. Now let's look at the acidic salts. Salts which are formed after the reaction between a strong acid and weak base are called acidic salts. The pH value of acidic salt is lower than 7. For example, ammonium sulfate, ammonium chloride, etc. Ammonium chloride is formed after reaction between hydrochloric acid and ammonium hydroxide, which is a weak base. Ammonium sulfate is formed after reaction between ammonium hydroxide and sulfuric acid, which is a strong acid. What are basic salts? Salts which are formed after the reaction between a weak acid and strong base are called basic salts. For example, sodium carbonate, sodium acetate, etc. Sodium carbonate is formed after the reaction between sodium hydroxide, which is a strong base, and carbonic acid, which is a weak acid. Sodium acetate is formed after the reaction between a strong base, sodium hydroxide, which is a strong base, and acetic acid, which is a weak acid. Cause of formation of acidic, basic and neutral salts. When the strong acid react with weak base, the base is unable to fully neutralize the acid. Due to this, an acidic salt is formed. When a strong base reacts with weak acid, the acid is unable to fully neutralize the base. Due to this, a basic salt is formed. When equally strong acid and a base react, they fully neutralize each other, and due to this, a neutral salt is formed. What is the pH value of salt then? Neutral salt, the pH value of a neutral salt is almost equal to 7. The pH value of acidic salt is less than 7 and pH value of basic salt is more than 7. Common salt or sodium chloride. Sodium chloride is also known as common or table salt. It is formed after the reaction between sodium hydroxide and hydrochloric acid. It is a neutral salt. The pH value of sodium chloride is about 7. Sodium chloride is used to enhance the taste of food. Sodium chloride is used in manufacturing of many chemicals. So important chemical from sodium chloride is sodium hydroxide, which is a strong base and it is also known as caustic soda. It is obtained by the electrolytic decomposition of solution of sodium chloride, which is brine. In the process of electrolytic decomposition of brine, which is aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. In this process, chlorine is obtained at anode and hydrogen gas is obtained at cathode as byproducts. The whole process is known as chlor-alkali process. Use of products after electrolysis of brine. Hydrogen gas is used as fuel, margarine in making of ammonia for fertilizer, etc. Chlorine gas is used in water treatment, manufacturing of PVC, disinfectant, CFC, pesticides. It is also it is also used in the manufacturing of bleaching powder and hydrochloric acid. Sodium hydroxide is used for degreasing of metals, manufacturing of paper, soap, detergent, artificial fibers, bleach, etc. Bleaching powder. Bleaching powder is also known as chloride of lime. It is a solid and yellowish white in color. Bleaching powder can be easily identified by a strong smell of chlorine. When calcium hydroxide reacts with chlorine, it gives calcium oxychloride and water is formed. Aqueous solution of bleaching powder is basic in nature. The term bleach means removal of color. Bleaching powder is often used as a bleaching agent. It works because of oxidation. Chlorine in the bleaching powder is responsible for bleaching effect. Use of bleaching powder. Bleaching powder is used as disinfectant to clean water, moss remover, weed killers, etc. Bleaching powder is used for bleaching of cotton in textile industry, bleaching of wood pulp in paper industry. Bleaching powder is also used as oxidizing agent in many industries such as textile industry, paper industry, etc. So let's talk about baking soda. Baking soda is another important product which can be obtained using byproducts of chlor-alkali process. The chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. Bread soda, cooking soda, bicarbonate of soda, sodium bicarb, bicarb of soda or simply bicarb etc. are some other names of baking soda. What is the preparation method? Baking soda is obtained by the reaction of brine with carbon dioxide and ammonia. This is also known as Solvay process. In this process, calcium carbonate is used as a source of calcium as a source of carbon dioxide and the resultant calcium oxide is used to recover ammonia from ammonium chloride. What are the properties of sodium bicarbonate? Sodium bicarbonate is white crystalline solid but it appears as fine powder. Sodium hydrogen carbonate is amphoteric in nature and is sparingly soluble in water. Thermal decomposition of sodium hydrogen carbonate, that is baking soda. When baking soda is heated, it decomposes into sodium carbonate, carbon dioxide and water. Sodium carbonate formed after thermal decomposition of sodium hydrogen carbonate decomposes into sodium oxide and carbon dioxide on further heating. This reaction is known as dehydration reaction. What are the uses of baking soda? Baking soda is used in making baking powder, which is used in cooking as it produces carbon dioxide which makes the batter soft and spongy. Baking soda is used as an antacid. It is also used in toothpaste which makes the teeth white and plaque free. Baking soda is used in cleaning of ornaments made of silver. Since sodium hydrogen carbonate gives carbon dioxide and sodium oxide on strong heating, thus it is used as fire extinguisher. Let's talk about baking powder. Baking powder produces carbon dioxide on heating, so it is used in cooking to make the batter spongy. Although baking soda also produces carbon dioxide on heating, but it is not used in cooking because on heating, baking soda produces sodium carbonate along with carbon dioxide. The sodium carbonate thus produced makes the taste bitter. Baking powder is a mixture of baking soda and a mild edible acid. Generally, tartaric acid is mixed with baking soda to make the baking powder. When baking powder is heated, sodium hydrogen carbonate decomposes to give carbon dioxide and sodium carbonate. Carbon dioxide causes bread and cake fluffy. Tartaric acid helps to remove bitter taste due to formation of baking soda. Washing soda or sodium carbonate. Preparation method. Sodium carbonate is manufactured by thermal decomposition of sodium hydrogen carbonate obtained by Solvay process. The sodium carbonate obtained in this process is dry. It is called soda ash or anhydrous sodium carbonate. Washing soda is obtained by rehydration of anhydrous sodium carbonate. Since there are 10 water molecules in washing soda, hence it is known as sodium bicarbonate decahydrate. Sodium carbonate is a crystalline solid and it is soluble in water when most of the carbonates are insoluble in water. Let's look at the uses of sodium carbonate. It is used in cleaning of clothes, especially in rural areas, in making of detergent cake and powder, in removing permanent hardness of water. It is used in glass and paper industries. The water of crystallization. Many salts contain water molecule and are known as hydrated salt. The water molecule present in the salts is known as water of crystallization. For example, copper sulfate pentahydrate. Blue color of copper sulfate is due to the presence of 5 molecules of water. When copper sulfate is heated, it loses water molecule and turns into gray-white color, which is known as anhydrous copper sulfate. After adding water, anhydrous copper sulfate becomes blue again. Let's summarize this chapter quickly. Acids. Substances which turns blue litmus solution red are called acids. Acids are sour in taste. Bases are the substances which change red litmus solution blue are called bases. They are bitter in taste. Mineral acids. Acids which are obtained from minerals like sulfates, nitrates, chlorides, etc. are called mineral acid. For example, sulfuric acid, nitric acid, hydrochloric acid. Organic acid. Acids which are obtained from plants and animals are called organic acid. For example, citric acid, ascorbic acid, tartaric acid, lactic acid and acetic acid. Hydronium ions. They are formed by the reaction of hydrogen ion and water. It is because of hydrogen is unstable. Universal indicator. A universal indicator is a mixture of indicator which shows a gradual but marked series of color changes over a very wide range of change in concentration of hydrogen ions. Strong acids. Acids which dissociate into ions completely are called strong acids. For example, H2SO4 and HCl. Weak acids. Acids which do not dissociate into ions completely are called weak acid. For example, citric acid and acetic acid. Chemical properties of acid. Acids react with active metal to give salt and hydrogen gas. Acid react with metal carbonates and metal hydrogen carbonate to give salt, water and carbon dioxide. Acids react with bases to give salt and water. This reaction is called neutralization reaction. Acids react with metal oxide to give salt and water. Chemical properties of bases. Reaction with metals. Certain metals such as zinc, aluminum and tin react with alkali solutions on heating and hydrogen gas is evolved. Reaction with acid. Bases react with acid to form salt and water. Indicators are substances which indicate the acidic or basic nature of the solution by their color change. pH scale is a scale for measuring hydrogen ion concentration in a solution. The pH of a solution defines as the negative logarithm of hydrogen ion concentration in molecules per liter. pH is minus log of hydrogen ion. The pH of neutral solution is 7 acidic is less than 7, and that is of basic is greater than 7. Some important compounds and their usage. We all know washing soda is used in manufacturing of borax, caustic soda, and softening of hard water. Baking soda is used as antacid or ingredient of baking powder. Bleaching powder bleaches clothes and used as oxidizing agent, disinfecting water and manufacture of chloroform, and plaster of Paris plastering fracture bones, making toys, decorative materials, and statues. Equations of acid, bases, and salts. So acid plus metal gives salt plus hydrogen gas. Base plus metal gives salt plus hydrogen gas. Base plus acid gives salt plus water. Acids give hydronium ions in water, and bases generate hydroxide ions in water. Reactions of important chemical compounds. Preparation of bleaching powder. By the action of chlorine on dry slate lime, CaOH twice plus Cl2 gives CaOCl2 plus water. On heating baking soda liberates carbon dioxide. Preparation of plaster of Paris. On mixing of plaster of Paris with water, gypsum is obtained.